Tech Revision with Mrs. Swanee Pooh. Hello, another video about materials. How exciting. This one is all about metals. So I'm going to go through all of the different metals that you need to have an awareness of and a familiarity with, so that you feel a bit more comfortable, hopefully, talking about these in the exam. So this is straight from the spec. This is what was in there, the things that you needed to make sure that you understood and that you were happy with. So on the left there, it's talking to you about different types of stock forms of metals, so making sure that you're aware they come in different stock forms. And also on the right hand side, these are the different types of metals that you need to have an awareness of. I feel like I say that a lot, you need to have an awareness of this. It doesn't mean that you need to have loads and loads of information. You don't need to know about their melting points or their specific densities or anything like that. You just need to know a few properties and a couple of uses, or a use of the material, and why that makes it suitable. So we're going to go through each one. The first thing we're going to talk about is the stock forms. So again, just to recap, stock forms of metals, or stock forms of any material, they are basically the pre-made or standard sizes that you can buy materials in. So if you think, why do we bother with stock forms? Stock forms are to do with making it easier for the manufacturer to supply a set amount of materials. They can't stock every single measurement and size and thickness of material possible. So they have these stock forms. Designers, engineers, manufacturers know that materials come in these stock forms, therefore they can design their products to use these. It also means they're easier to transport, they're easier to store, it makes it cheaper all round for everyone. So these are the ones that you need to have an awareness of. Metals can come in a sheet, so quite often used for press forming of car doors, car bodies. You get different thicknesses, and that's called gauge of different metals. Metals can also come in plate. This looks a little bit like sheet, but it tends to be slightly narrower, so it comes in almost like a narrow strip, and it tends to be a bit thicker. You can get them in bar. This just means solid, so it doesn't have to be a square section like the one on the picture here. It can be round, it can be hexagonal. So if it's a solid piece of aluminium bar, that's what it is. It's a bar. Okay. Tube, obvious, it's hollow, but it can be square, round, or hexagonal. It doesn't have to be circular. And then we get to the different shapes. So this did come up in an A-level exam once. They asked to name certain profiles of metals, and they also asked about why a certain profile was used in construction. So we've got T-bar here, shaped like a T, not hard to forget. We've got H-beam and we've got I-beam, which, if you think about it, look very similar if you turn them on the side, but there is a slight difference. In the H-beam, you'll notice that all the angles are kind of right angles, but on the I-beam, it's got this kind of slightly curved shape, just where the middle of the eye goes up onto the top bit. You can see it kind of curves away. So I-beams are designed to resist bending. They're designed to handle uniform loads. So they're quite often used on flooring, under flooring and all that sort of stuff, because they distribute the force evenly over a large surface area. Then you've got other types of metal section, L-beam, and you've got channels. So these all have slightly different applications. I can't imagine you would be asked anything too difficult that isn't common sense about these materials, but just to have an awareness of what each of these are, and making sure that you could name them if you saw it in front of you, you go, oh, okay, that's a channel, or that's a T-bar, or whatever. Okay. So next, there are three categories of metals that you need to make sure that you understand. So we've got ferrous, non-ferrous, and alloys. Alloys is also split into two different parts. You've got ferrous alloys and you've got non-ferrous alloys. So ferrous, just to begin with, contains iron. They're magnetic. They can rust. So they often need a protective coating. Non-ferrous Non-ferrous is the opposite. They do not contain iron, they're not magnetic, they do not rust, so they're quite often useful outdoors or if they're going to be exposed to moisture or things like that. And alloys are one or more elements or metals combined together, and they are combined. I've seen this question before in an exam. They ask you, why are metals alloyed together? You know, why are they combined? And they are often combined to give useful properties, to give the material a property it did not have before. The classic mistake I see people do or make is they say they are combined together to make them stronger. Well, that's not necessarily true. They could be combined together to give any kind of property. It could be to give it corrosion resistance, or to give it more tensile strength, or to give it hardness. You need to make sure that you're talking about the properties, enhancing the properties, and you could always give a few examples. For example, stainless steel has chromium added to it, which stops it corroding or rusting. Okay, so those are the three kind of main types that you need to be happy with. And the first one we are going to talk about is the ferrous metals that you need to be happy with and you need to know. So first one, very, very common steel. One of the most common steels that you'll find around. It's readily available. It's mostly iron mixed with a very small amount of carbon. So that's what steel is iron mixed with carbon. And the type of steel then depends on how much carbon you add. It changes the properties massively. But low carbon steel, because it doesn't have too much carbon in it, it means it's quite ductile, so it can be pulled into a wire. It makes it very malleable, so it can be hammered and pressed into shapes without fracturing, but also it rusts easily, so it needs a finish on it. So the uses, you've got nuts and bolts. These nuts and bolts have been coated in a zinc or a tin finish to make sure they're not going to corrode. You've got car bodies. So low carbon steel is the main material used in press forming of car bodies because of the reasons that we just spoke about. And most things, low carbon steel, will need some kind of finish. For exterior products like girders and gates, they could be galvanized with zinc, a zinc coating. Car bodies, it's going to be paint. Okay, so low carbon steel, there we go. Next one. This one is called high-speed steel. Now, the clue is in the name. This steel is used where any like drill bits or lathe tools or anything that needs to spin or is going to touch something that is spinning at a very, very high speed. Okay, so the uses for this steel are things like drill bits, lathe tools. So lots of you have used the metal lathe with Mr. Johnson doing your different projects. Those tools will be made from high-speed steel. Anything that's going to be spinning at a high speed is going to need certain properties. Firstly, it's going to need to be very hard and very durable. It tends to be quite brittle. So drill bits, I don't know if you've ever noticed, they do break quite quickly if you're not careful. They can just really easily fracture. So they're not tough, they are quite brittle, but they are hard. They're resistant to wear. And the most important thing is they're resistant to abrasion and high temperatures. So the friction and the heat that's generated at those high temperatures is not going to affect the drill bit. It's not going to melt. It's not going to wear away. It's not going to deform. So that's what this is. High-speed steel is used on things like drill bits, lathe tools, where something is moving at a high speed. So that's the first two, low carbon steel, high-speed steel. Next one, medium carbon steel. Oh, I haven't done my transitions properly on this one, so just to look at the top section for the moment. Medium carbon steel has got a little bit more carbon in it. And what that means is it can actually be heat treated. Now, what this means is, if any of you have ever watched any videos about working with metals, and I'm sure lots of you have, you will notice that they heat metal up and they might quench it, so put it into a bath of water or oil, and they usually do that to achieve a certain property. So for example, with things like swords, for example, you want a very hard outer edge that can be ground and create a very sharp edge, but you want the middle of the sword to be almost a little soft so that it's going to be able to have a bit of toughness, so that it's not going to be very brittle. It's going to be able to flex slightly so that it can resist the impact. So medium carbon steel allows you to change the properties because it can be heat treated, and it's often used for things that are in mechanisms. So medium carbon steel, think mechanisms for gears, for axles, for cams in engines and levers. It balances good strength but also good ductility, a bit of malleability in there as well, and it has good wear resistance. I hope that makes sense. So so we've got low carbon steel, then we've got medium carbon steel, so it's got a bit more carbon in it, which means you can heat treat it, which makes it to achieve different properties. Now, completely different, this is not steel at all, this is just cast iron. So pure iron, directly from its ore. It's very soft, it's very ductile, but when it's cast, so usually it's melted, heated up, melted, and poured into molds, it can make it quite brittle. So for example, things like, one of the uses is metalwork vices, the ones that you use at school to put metal in, those really heavy ones. If you were to drop that, there would be a chance that it could break and fracture because it's quite brittle on impact. Things like cast iron pans, so those posh heavy pans that people have, those coloured ones, the very expensive ones, they're cast iron. It's very strong in compression, so that's why it's often used for things like, it's used for, what am I trying to say, things like, what's it on the anvil there, so when you're hitting it, it's compression, it's not going to be fractured, but it can be a little bit brittle. So cast iron, it's also very, very heavy. So quite often, if you want something to be very heavy, manhole covers, you don't want that to be easily lifted off. That's why cast iron is a good material. Okay, that's the first 4, and those are your ferrous metals that you need to know. Next ones are non-ferrous metals. So the ones that you need to know for this are the classic aluminium, very common material, the most abundant metal ore, I think, on the planet. It's got a really high strength to weight ratio. That's the big thing that you need to remember about it. It's very light for how strong it is. And also another really important thing that isn't actually on there, so if you are making notes as I blabber on, you will want to write down that it's really, really easy to recycle. When you recycle it, it can be used over and over and over and over, so it can be endlessly recycled without breaking down. It doesn't degrade or lose any of its properties. So it's a really recyclable material, and you'll notice now that some drinks companies are starting to supply like water and things in aluminium cans because they can be so easily recycled and used for the same purpose. So plastic bottles can be recycled, but often they can't be used for the same purpose again. They'll be used for something else. So aluminium is a great material. It can be difficult to join, and by that I mean welding. So often you have to do something called TIG welding, which is tungsten inert gas, which is quite a difficult welding process, but it's very lightweight, so it's used in airplanes, it's used in drinks cans, ladders, anywhere where you need a good strength but a very lightweight product. Next one is copper. The big one about this obviously is that it's a very good electrical conductor. It's very malleable and it's very ductile, so it can easily be stretched out into pipes, into wiring. So it's used in electrical wiring in pipes. Sometimes it's used in like jewellery because it's so soft and easy to form. So copper is a very valuable material. It's quite expensive. My husband's from South Africa, and he always told me that quite a classic thing that they used to do is dig up the copper wiring from under the ground. They dig it out of the ground and then attach it to a motorbike or a car, and basically pull the entire copper wire out of the floor, out of the earth, because it's so expensive. They go and sell it. So copper is a very valuable material because of these properties that it's got. Tin. Tin is a very soft material. It's got a very low melting point, so it's quite often used in solder for electrical, for attaching electrical components. It's ductile, meaning it can be pulled into wires. Quite often it's used as a coating on tin cans. So the cans aren't actually made from tin, they're made from a mild steel, like a low carbon steel, and then coated in tin, because then it's going to give it that non-ferrous advantage of not rusting or corroding. And obviously it's used in things like tin foil. Being so soft and malleable, it can be squashed into very, very thin sheets. So that's tin. And zinc. Zinc is not a very strong metal, but the massive kind of benefit of it is it's used predominantly in galvanizing. So it does this very clever thing where it forms a chemical bond with steel that gives it a lot of strength and it protects it. So for example, even when the steel is scratched and the steel is exposed under the zinc will still protect the metal. So it gives it a really, it's like a chemical kind of reaction that happens. So galvanizing, coating steel in a protective layer, and the way that they do it is they basically get massive steel, normally things like, you know, like motorway barriers and lampposts, big metal products, dip them in a massive bath of molten zinc, and there we go, you've got your galvanized product. The next one that you need to be aware of is silver. Silver's actually got some really interesting properties. The first thing that you'll think about is, well, jewelry. It's used in jewelry, but actually it's one of the best conductors of heat and electricity. So it's used a lot in electronics, in soldering, in solar technology to transport energy. It's used in all sorts of different things, but also jewelry, because it's very ductile, it's very malleable. That also makes it really useful for electronics, meaning it can be squashed and made into very thin sheets. Also, it's very lustrous, so it can be polished and finished to a really high quality finish, making it suitable for jewelry. It also is often used in surgical equipment. It has an antibacterial property, so bacteria doesn't grow on silver, which makes it very, very useful for those kind of medical applications. So that's quite an interesting property of silver. And the last one is gold. So gold, again, silver and gold, the two that you'll think actually, well, they're both jewelry, but they are used so much in electronics, mostly because of how efficient they are at conducting. So gold is a really highly efficient conductor of electricity and heat. It's really, really ductile. It can be drawn out into a tiny, tiny thin wire. It's highly reflective of heat and light, making it useful for space. You know, there's quite a lot of gold that was used on the Webb telescope. It's obviously prized for its beauty, therefore it's used in jewelry. It's malleable, you can make it into extremely thin sheets, so think about gold leaf, how thin that is. It's very dense, it's quite heavy, and interestingly it's non-allergenic, so that's why it's quite useful for things like jewelry and medicine and dentistry, if you think about gold fillings. Bit bling, but there we go. But actually it has those non-allergenic properties. Because it's in contact with our skin and our bodies, it's not going to react. So gold, you'll find a lot of gold actually in electronics like smartphones and things like that, used in the circuit boards and the components, because it's such a highly efficient conductor. So that's a couple more non-ferrous. There is one more non-ferrous, I believe, which is titanium. Titanium is a really brilliant material. It's lightweight. It's kind of often compared to aluminium, but it's actually much lighter compared to even aluminium, which is known for its lightness. Lightness, is that a word? It's how light it is. So it's lightweight, it's got high strength, low corrosion, and it's often used in things like aircraft, so jet turbine blades, you know, high-speed aircraft, jets and things that we're talking about. So it has a high melting point, which obviously makes it useful for things like jet engines. And it's as strong as steel, but weighs about half as much, which is an amazing property to have. So that's why it's used in all of these applications. So things like it being used in hip joints, obviously it's not going to corrode. It is very lightweight, it's very strong, used in high quality kind of golf and sports equipment, bicycle frames, surgical tools. But think about it as it's quite often the kind of step up from aluminium, very expensive, but it's for high performance products. Right, now that we've spoken about those two main ones, we're going to talk about ferrous alloys now. So these are ferrous metals combined with other metals to create alloys. So the first one, this one, is called die steel, and it's called tool steel. So basically this is what most tools are made from. So think about hammers, screwdrivers, you know, there's a tap and die set there at the top, quite often used for the molds and the formers used in industry. So for example, when you injection mold something, I talk about quite often about how expensive those molds are. They're often made from die steel, so tool steel. And things like you know, punches and center punches and things like that are made from tool steel. So where you might be thinking, well, hang on, what about high-speed steel? That was used for things that were spinning or were going to be moving at high speed. This is just for tools that need to have good resistance to wear, good stability, and high compressive strength. So it's a mixture of high carbon steel and chromium. So chromium is an element actually that limits corrosion. So you put that into the steel, it stops it rusting to some extent. But this kind of steel is used in industry on those big bits of machinery that create products, and also any tools around the workshop would be made from die steel, or you can call it tool steel if you find it easier to remember. Next one that you need to know is a classic stainless steel. This is called a non-ferrous alloy because it is a steel, so it is ferrous, but it has a bit of chromium, nickel, magnesium, a few different bits and bobs added to it, which makes it resistant to corrosion and wear. So it's quite often used in sinks, stainless steel sinks, because it can be polished to a really high quality finish. It's going to look really attractive, but it doesn't scratch easily, it's not going to rust. And for cutlery, and also surgical instruments. So those are the main sort of uses for stainless steel. So there we go. Those are the ferrous alloys that you need to know. We're now going to talk about the non-ferrous alloys. So these are different non-ferrous metals that have been mixed together. First one being bronze. So a lot of these are kind of ones that you would think about like that would be made kind of more decorative, I would say, than kind of functional, because quite often they can be a bit softer, and sometimes they can have more of an attractive kind of finish to them. So bronze is a mixture of copper and tin. Bronze is a highly ductile metal. What's really interesting is that it expands slightly as it solidifies. So if you melt it and pour it into a mold, as it cools and solidifies, it actually gets slightly bigger. So what's good about that, and what makes it really useful for things like statues, it's going to fill the mold completely as it cools, and it has quite a bit of a lower melting point than iron or steel, making it suitable for things like statues and medals, things that need to be cast. So you can see there's a few different products that are used, but just try and remember that this one is quite often used for statues or medals or things like that. So that's bronze. Brass is a mixture of copper and zinc. It has a much brighter gold kind of look to it rather than bronze, which is a bit darker. It's often used for musical instruments, door handles. It's quite an attractive material. It looks good if you like that kind of look. And in terms of it being functional for the brass instrument, it gives a lovely tone and a lovely aesthetic quality, but also because it's malleable and ductile, it's easy to shape and form into all of those intricate shapes and components. So that is brass. Pewter. We use pewter in school quite a lot. You might remember back in year 7 when you did the zip tag, that was pewter that we used. It's relatively expensive for schools, but it's actually got a ridiculously low melting point. You could actually melt it on your hob at home. I think it melts at about 200 degrees, something like that. So it's mostly tin with a little bit of copper and antimony, which is, I think, some kind of element that helps it its fusibility, which, remember, if you think about material properties, is how easy a material goes into a liquid. So it's known for its malleability, its ductility. It's very soft. You could literally, if it was thin, you could literally bend it in your hand. It's very soft. It resists tarnish, so it keeps its nice colour and finish indefinitely. And it's mostly used for kind of decorative items like bits of jewellery. It was also often used for things like tankards and goblets and statues and stuff. So pewter is often used in school for pewter casting because it's got such a low melting point, and because it's so soft and easy to work with. That tends to be quite good for those kind of applications. And the last one today is this one. This one is called Duralumin, which I find really weird and strange to pronounce. But this is an alloy of aluminium. So it's aluminium with copper and magnesium. It's mostly aluminium, but those additions of those two materials give it quite a few different properties. The main property being it has a lot better tensile strength than aluminium. So tensile strength, remember, is a material's ability to resist stretching forces. So it's strong, it's lightweight, the same as aluminium, but it's got a lot better tensile strength. So if you think about it being used on the body of an aircraft, there are going to be stretching forces across the body of that. I don't know if you guys remember a monocoque aircraft, which is where the strength of the product is in the shell of it, almost like an egg. And the egg is a monocoque structure because the strength of it isn't in the shell. So on an aircraft, the shell needs to be very, very strong. So duralumin has that extra tensile strength, which is often lacking sometimes in aluminium. So duralumin is a common alloy used in aircraft. Right then, another almost half an hour of me blabbering on about materials, but I hope that was useful. Go back through, make some notes, mute me if you just want to see the key important bits, but I hope that was useful. And the next one I'm going to do is hopefully going to cover some of the polymers, so I'll see you on the next one.